If you're a Leaving Cert high-level math student and you currently don't like logs, please give me 25 minutes of your time and we'll fix that. So what do logs do? First of all, logs can, but we don't need them to solve situations like this. The reason we don't need them to solve scenarios like such, which is 4 to the power of 2x plus 1 equal to 64, is because that 64 is playing nice. What do I mean by playing nice? I can write it as a base 4. So I have 4 to the power of 2x plus 1, and instead of writing 64 as 64, let's dress it differently. Let's have it written as 4 to the power of 3. Now what we have is a situation where we 4 to the power of something equals 3. So hopefully you realize then that that something up there, the 2x plus 1, must equal 3. To finish then, 2x is going to equal 2. Therefore, x is going to equal 1. Now, that can be solved using logs, but as you saw there, it's quite unnecessary. This situation, however, 2 to the power of x equals 27. So basically what we're being asked is 2 multiplied by itself how many times equals 27. And you as a Leaving Cert high-level math student should be able to solve that, okay? And this is where logs come in. So over the course of the next 25-30 minutes, we're going to answer all past Leaving Cert higher level direct logarithm questions back as far as I think 2012. And you'll notice just how manageable this topic can be. What is a logarithm? You can read that sentence there in front of you, but basically all it is how many times I need to multiply one number by itself to generate another number. So if we look at this little box here, these can all be evaluated mentally by the student who's comfortable with their logarithms. So the first one, I have log of base 2 raised to 32. If you type that into your Casio, the number you will get is the number 5. Why? Because 2 to the power of 5 is equal to 32. If I come one right, I now have log of base 3 raised to 81. That, hopefully, you're beginning to realize is going to be 4, because 3 to the power of 4 is 81. Then the next guy, we have log of base 5 raised to 25. That's going to be 2, because 5 squared is equal to 25. And this guy on the right-hand side, if you're confident with your laws of indices, you should know that that's going to be equal to 0, because anything, 16 included, to the power of 0 is 1. And we'll cover that at a later time in our indices session. So using that logic, let's solve each of the following. Again, we can do these somewhat mentally. So this statement here is communicated to me in the language of logs. Okay, so it's up to me as a Leaving Cert high-level student to be able to interpret what that's saying to me. And all this is saying to me is the following: that this little number here to the power of this is equal to that big fella there. Okay, so just keep in mind that cyclical motion. The little fella is equal to some value to generate the large one. So in other words, x to the power of 3 is equal to 64. And now we can solve. So we'll take the cube root of both sides, and we get our single positive x on the left-hand side, which is what we're after. And the cube root is 64, which means what number multiplied by itself 3 times is 64? Well, that's 4, and you can use your Casio if you don't believe me. Moving into the center then, we have log of base 5 raised to x equals 3. So what does that mean? So if I come back here and we'd use that same cyclical motion here, I have this fella here to the power of that over here is that thing there. So what does that look like? 5 to the power of 3 is equal to x, and 5 to the power of 3, if my mental maths serves me, is 125. Okay, and then we come to this scenario. This is simply saying 6 to the power of what? Or 6 multiplied by itself, how many times is 1296? So can we write this in logarithm language? So if we go back to that previous example that we looked at, it's log of the small guy raised to something equals the big guy. So the big guy here is the 1296. So that statement there is what I need to type into my calculator. 6 to the power of what is 1296. And that's the language I need to speak to my Casio. So I press my log, I put in my 6, I put in 1296 in the large bracket that automatically opened, and we get out the number 4. So that means 6 to the power of 4 is equal to 1296. and 96. Okay, so that's all a log is, and it's nothing more than that. So there's no need to be intimidated by logarithms. We just have to be confident using them. And by the end of today's lesson, I promise you will be, because you'll have every past exam question answered in the world of logs. Just there you saw me use my Casio. Okay, so calculator skills are important. You'll see we have three different kind of buttons on our Casio. We have the log to a small box and a large box. So basically that's just below the on button on my calculator. So just familiarize yourself with your own calculator. But really what that allows me to do is put in any base number and raise it to any power. So that button there is usable in 100% of circumstances. This guy here, the LOG button, that gets its own little button because this is log of base 10. The reason it gets its own button is because scientists, engineers, and other people in other fields often use ridiculously large numbers or ridiculously small numbers that can be expressed as a power of 10. So because they use it so often, it gets its own button on the calculator. Finally, we have the natural logarithm button, okay? And this is a pre-programmed log of base e. Now, e, I've given a brief explanation of what that is here. But for us as Leaving Cert Maths students, we don't really care about e or what its value is. Treat it the same way you would pi. It's approximately 2.7. But if you were to pursue maths in university level, you might become more familiar with e. But for us, that's all we need to know about it. Okay, so we'll treat it like any other constant. The laws of logarithms now, this is where we need to be comfortable and confident, and there's no need not to be, because these are all contained on page 21 of the formulae and tables booklet that you'll be handed on the day of the exam. So we just need to go to page 21 anytime we do a direct logs question and apply the laws. Okay, so these laws are just a series of shortcuts that someone very clever has put together for us, so we can just take the numbers and input them to the laws and get on with our lives. When I introduce them to students though, I like to use values that we can mentally calculate, because if these laws stand true for very small, digestible, easy to visualize numbers, then they're going to do the same when the numbers get a little bit messier, as we'll see when we go into the exam papers in a couple of minutes' time. So if we look here, the first law, call it what you want. I like to call it the product law. Just means if you have a logarithm with something being multiplied by something, you can separate the two somethings into their own individual logarithms. So if we were to calculate this first one, okay, 4 times 8 is 32. 2 to the power of what is 32? 2 to the power of 5. So this value here is equal to 5. If someone typed that into the calculator, they get 5. Using the laws, we should be able to break that into two parts. So we should be able to write it as log of base 2 raised to 4 plus log of base 2 raised to 8. And now if we break each of those down, 2 to the power of what is 4, that's 2, and 2 to the power of what is 8, that's 3. And of course, 2 plus 3 is 5, so we're happy that that law stands true. Moving one beneath, law 2 is the quotient or the division law. Again, call it whatever you want, just know how to use it. This just means if we have division, we can separate into subtraction. So again, looking once more here into the center, 32 over 16 is 2. And then 2 to the power of what is 2? 2 to the power of 1. So all that crap there is just the number 1 if you type it into your calculator. But let's apply the law. We should be able to break into two parts. Log of base 2, 32, minus log of base 2, 16. Okay, let's do the mental maths here. 2 to the power of what is 32? 2 to the power of 5, of course, and 2 to the power of what is 16? 4. So 5 minus 4, that equals 1. Okay, we're happy. Coming over here, please, 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 if you take nothing more from this lesson, is remember this. If you wanted a really, really bad tattoo, this is the one to tattoo on yourself. It might help you out on the day of the exam. This basically is the power to a coefficient law, or the coefficient to a power law. So what does it look like? This is just saying that if I have a logarithm with a power in its index, okay, so here we have 4 to the power of 3, I can come along and bring that power down as a coefficient. So this guy here can be rewritten as 3 times the log of base 2 to the power raised to 4. Okay, so if we just look at it for a second, in this bracket I have 4 cubed, which is 64. Okay, and 2 to the power of what is 64? I think it's I'll just clarify on my calculator, not be guessing, but it's 6, okay? So this here should give us the value 6 because 2 to the power of 6 is 64. So let's see if the right-hand side does that. First things first, let's calculate this in our head. 2 to the power of what is 4? 2 to the power of 2 is 4. And then what's 3 times 2? That is, of course, 6. So what we have here is 3 times 2, and we both know that that's equal to 6. Okay, so please remember the power to coefficient law. We're going to see that several times over the course of the next few exam questions that we do. The next law then, law 4, is the zero law. And this very simply means that any base raised to 1 will be equal to 0. We would have saw that in detail in our laws of indices session. So if you have 2 to the power of something equaling 1, you are going to get 0. Okay, so again, you can type that into your calculator, log of base 2 raised to 1, and you probably can't see it on the screen, but you can see it in your own calculator. That gives me an answer of 0. Again, that goes back to our laws of indices, and hopefully you remember that session. Here then we have the negative law, and this then comes back actually to the power to a coefficient law. The reason being, I'm about to use one of our laws of indices again. So instead of writing 1 over 2, I'm going to write that as 2 to the power of minus 1. Again, if you type 2 to the power of minus 1 into your calculator, you're going to get a half. And now you'll see that I have a power, okay? So once I see a power, that power there can drop down in front of my logarithm. So I'm going to do that, just that. I'm going to rub out my minus 1 here. And I'm going to drop it down here in front. So it's at negative log of base 2 raised to 2. This guy here is the identity law. And really that just comes down to understanding what exactly a logarithm is saying to you. So if we look here, this is saying 2 to the power of something is 2 to the power of 3. So I'll say it one more time. 2 to the power of something is equal to 2 to the power of 3. So hopefully you realize that that something is 3. Okay, so all that stuff written there in the center column is just equal to 3 because 2 to the power of 3 is equal to 2 to the power of 3. Finally, that brings us to the change of base law. And the change of base law is really, really, really easy to use. Okay, you can change the base of any logarithm you want. The reason we're going to end up doing that is because the laws of logs rely on matching base numbers. So in certain years, they'll give you a logarithm equation. The left-hand side might be written in log of base 2. The right-hand side might be written in log of base 3. Okay, so you cannot apply the laws of logs to solve that equation because you have bases which don't match. So in order to match the bases, you can commit to changing the log of base 3 or the 2 using the change of base law. So once more, for the final time, this here is saying log of base 9 raised to 81. That's equal to 2 because 9 to the power of 2 is 81. The change of base law, very simply, if you want to think as a shortcut, is introduce any new base number you want. For the sake of this example, I've used the number 81, or sorry, I've used the number 3 just because that will work nicely with 81 and 9. That big guy here, so the big guy I'm referring to is the 81, that stays on top. So big guy stays on top and little guy, which in this case is 9, will drop down to the bottom. So think base number, which is the little guy, drops down to the denominator while the big fella stays up on top. So now we can evaluate here. 3 to the power of what is 81? That's 4 because 3 multiplied by itself 4 times is 81. And then here, 3 to the power of what is 9? That's 2 because 3 squared is 2. Or 3 squared is 9 even. And what's 4 divided by 2? That is 2. So you can see, once again, our values are matching. So the change of base law, really easy to use. Just think, bring in your new base, whatever you need to do, and then keep the big value on top and drop the little guy into the denominator. Okay, so I think that's now all we need to know to solve every past direct logarithm question that's ever been asked. So let's go through a few. This is a familiar enough site where the examiner will give you, a game of matching. Okay, so they'll tell you that P in this case is equal to something. So this P here is equal to log of base 2 raised to 2. Then they'll tell you that this Q is equal to log of base A raised to 3. And then they'll give you stuff where you need to break it down and express it in terms of P's and Q's. So they force your hand to be confident with your logarithm laws and not just being able to type something into a calculator, okay? Because you're not going to be able to get a P and a Q typed into your calculator. So let's start with the first one. So I'm highlighting on screen here. The first one here, we have log of base A raised to 8 over 3. Hopefully you notice that's division, so I'm immediately going to jump into footed on this one, and I'm going to have log of base A raised to 8 minus log of base A raised to 3. Now, I'm very happy with this part of the logarithm that I've just broken into two, because I can straight away see that that can be replaced with Q, so I'm happy with that. But this guy over here, I currently have raised to 8, so I haven't the opportunity in this style to bring in a P or a Q. But you'll notice that I can easily represent the number 8 in base 2. So I'm going to do just that. Log of base A, instead of 8, let's write 2 to the power of 3. And then over here, we can get rid of our log of base A raised to 3 and put straight away our Q in. Now, a second ago, I told you to pay particular attention to this style, okay, of logarithm, the power. So I'm going to bring this power down as a coefficient, and our question's done, because I'm going to get 3 times log of base A raised to 2 minus Q, and that 3 times log of base A raised to 2, I'm just going to remove this guy here, because we know that that's equal to P. It's highlighted at the top of your screen there in the question. So I can write that, my final answer, as 3P minus Q, and I've got myself full marks. Part 2 of the question then is very similar. So once again, I'm going to jump into footer on it, because I can immediately at a glance see that I have division. So that's about to be broken into 2 separate parts through subtraction. So let's do that first. I have log of base A. This is 9A squared. And then I'm subtracting log of base A, 16. Now, if we look closer to this part here, that's 9 multiplied by A squared. So I think was it law 2 or 3 where we looked above where it was multiplication. I'm going to separate that multiplication or that product into 2 separate logarithms using addition. So that now is about to be written as log of base A 9 plus log of base A squared minus log of base A 16. Okay, now it's time to play the matching game. So what do I mean by that? Remember, we have to bring in a base 2, or sorry, we have to bring in a 2, and we got to bring in a 3. So first things first, let's go after this 9, and let's rewrite it as log of base A raised to 3 squared. Here now in the center, we have our identity law, okay? That is log of base A raised to A squared. So what that's saying to me is A to the power of what is A squared. So straight away, let's just write 2, of course, because A to the power of 2 is A squared. And now I'm working with 16, so that's going to give me the opportunity to write log of base A again. But instead of 16, let's write that as 2 to the power of 4, because that's another way of writing 16. Now, just to give myself more space, I'm going to get rid of my previous question here, and we'll work over here on the left-hand side column. Okay, so that won't rub out too quickly, but we'll try again on that. And let's see if it rubs out this time. Okay, happy out. Right, let's now work up here. So this 2, the power, is about to come down as a coefficient. So we're going to get 2 log of base A3. Then we have our 2, which we're happy with. We can't get any more simple than that. And that power of 4 is about to drop down, and it's minus 4 log of base A raised to 2. And now look what we have. We have the ideal scenario. We have A raised to 3. Once again, we have a log A raised to 2. So now it's just a case of replacing like with like. So we're going to replace this guy with Q. We have the number 2. And I'm going to replace log of base A raised to 2 with P. So that's minus 4P. You've taken full marks, and it wasn't that bad. All right. We're now in 2014, so this was another question I found in the past papers that gives me the opportunity to practice my laws of logs, okay? So again, I can't rely on my calculator, so this is what we want when we're practicing. We want to be forced into using our laws of logs. So this time we've been given p, and p is equal to log of base c raised to x. So this is going to be easier than the previous one, because in the previous one we had a p and a q. This time we just have a p, so there's only one logarithm that we need to get the other guys in the form of. So let's start with the first guy. Log of base c, and that's raised to the square root of x. So remember, you need to be confident expressing your surd signs as fractional indices, because in the world of indices, surds, logarithms, we're better off operating with fractional indices rather than surd signs. So just a quick reminder, and we saw this in our indices class, and it's in your logbook, that the square root of any value is that value to the power of a half. So I'm going to straight away rewrite this as x to the power of half, and hopefully you're realizing what I'm going to do next with that, but I'll come back to it. And then this other guy over here, we have multiplication going on in that bracket. So straight away, let's break that into two parts. Log of base c raised to c, and we're going to add log of base c raised to x. And now I think we're more or less done, because that power comes down as coefficient, so a half times log of base c raised to x. This guy in here, we have our identity again. C to the power of what is c? C to the power of 1, because anything to the power of 1 is itself. And then the last guy here, I can straight away rewrite as p, because that's what p is equal to. And you'll notice over here, hopefully, that this is also now p. So I'm going to come in and write this as a half p plus 1 plus p. So in terms of p, that will suffice, or we can tidy up and we can say we have 3 half p's, so that's 3 over 2 plus 1, or maybe you prefer decimal, in which case you'd write 1.5p plus 1.